Good morning all students. Today we meet again in online learning SMPK Penabur. I hope all of us and all of our family still in a good condition. After previous meeting we learned about words and types of work. Today we will learn about relation between work and energy changes and power. Standard competence for our meeting today is understanding concept work, simple machine, and its application in our daily life, and connection with the work of Muscle on human skeletal structure. Firstly, we will learn about relation between work and kinetic energy changes. As we learned at the previous meeting, we know that magnitude of work is equals with the multiplication between force F and displacement S. How work has relation with kinetic energy changes? To understand about this, we will see the figure below. From the figure, we see that an object which has mass m moves with velocity v1. After that, the object is given by force F, so that the object moves with displacement s and the velocity of the object becomes v2. It means the object experiences accelerated motion, that the magnitude of displacement can be determined by this formula as equals v2 squared minus v1 squared over 2a. To get relation between work and kinetic energy changes, firstly we use formula work equals F times S, that F equals mass times A. So work equals mass times A times S. If we substitute S with v2 squared minus v1 squared over 2a, so work equals mass times A times v2 squared minus v1 squared over 2a. So work equals half times mass times v2 squared minus half times mass times v1 squared. So work equals kinetic energy 2 minus kinetic energy 1. So we can say that the magnitude of work equals delta kinetic energy. After we understand the relation between work and kinetic energy changes, now we will learn about relation between work and potential energy changes. To understand that, firstly look at the right figure. From the figure, we see that the ball falls from position 1 up to position 2 because of gravitational force. So work on the ball is work equals F times S. That F is caused by the weight of the object. So work equals weight times S. That S, from the figure we see that S equals H1 minus H2. So work equals mass times acceleration of gravity times H1 minus H2. So work equals mass times acceleration of gravity times h1 minus mass times acceleration of gravity times h2 equals potential energy 1 minus potential energy 2. So work equals minus delta potential energy, or the magnitude of work can be written work equals delta potential energy. So from this we can conclude that relation between work and kinetic energy can be formulated with work equals delta kinetic energy, and relation between work and potential energy can be formulated with work equals minus delta potential energy. To get more understanding about relation work and kinetic energy changes and relation work and potential energy changes, now we will see example 1 and example 2. Firstly, we will see example 1. A force is given on an object which has mass 4 kilograms, so that the object velocity changes from 2 meters per second becomes 6 meters per second in 4 seconds with distance 8 meters. Calculate work on the object and magnitude of force that is given to the object. From the problems given, m or mass equals 4 kilogram. You should notice that the mass should in kilogram, and V1 equals 2 meters per second and V2 equals 6 meters per second, and S displacement equals 8 meters and T equals 4 seconds. Ask work W and force F. Answer: work equals delta kinetic energy equals half times m times V2 squared minus half times m times V1 squared. So work equals half times 4 kilograms times 6 meters per second square minus half times 4 kilograms times 2 meters per second square. So the answer for work equals 72 joules minus 8 joules equals 64 joules. And to get the magnitude of force, work equals F times S. 64 joules equals F times 8 meters. So magnitude of force equals 64 joules divided by 8 meters. So magnitude of force equals 8 Newton. Example 2. A ball which has mass 1 kilogram fall from the top of the house which has height 3 meters to the ground. Calculate work on the ball. From the problems given, m equals 1 kilogram, acceleration of gravity g equals 10 meters per second square, h1 equals 3 meters, ground is the reference, h2 equals 0 meter, ground is the reference. Ask work W. Answer: work equals minus delta potential energy equals m times g times h1 minus m times g times h2. So work equals 1 kilogram times 10 meters per second square times 3 meter minus 1 kilogram times 10 meters per second square times 0 meter. W equals 30 joules, or we can say the magnitude of work equals 30 joules. After we learn about relation work and kinetic energy changes and relation work and potential energy changes, now we will learn about power. Power is defined as the rate of doing work or using energy. A greater power is employed when a greater amount of work is done in the same period of time, or when the same amount of work is done in a shorter period of time. Hence, power can be formulated as P equals W over T, that P represents power, the unit is watt, and W is work, the unit is joule, and T represents time, the unit is second. SI unit for power is watt. Another unit for power is horsepower, HP. That 1 watt equals 1 joule per second, and 1 horsepower equals 746 watts. Because P equals W per T, so P can be written to as F times S per T. To get more understanding about power, let's see the example 1, example 2, and example 3. Now, let's see the example 1. An object which has weight 2000 Newton is lifted by a machine to the height 10 meters from the ground in 4 seconds. Calculate power of the machine. From the problems given, F equals weight equals 2000 Newton. In here, object move with constant velocity. S displacement equals 10 meter and time t equals 4 seconds. Ask P. Answer: to get P, first we have to find work. Work equals F times S equals 2000 Newton times 10 meters. So the work equals 20,000 joules. And to get power, power equals work over time equals 20,000 joules over 4 seconds. So the power of machine equals 5,000 watts. Example 2. Johnny and Brian push the stall car with forces 200 newtons and 300 newtons, so that the car moves 8 meters in 10 seconds. Calculate total power from Johnny and Brian. Given, force by Johnny equals 200 newtons, force by Brian equals 300 newtons, displacement S equals 8 meters, time t equals 10 seconds. Ask power P. To get total work, work equals sigma F times S equals 200 newtons plus 300 newtons times 8 meters equals 4,000 joules. Power equals work over time equals 4,000 joules over 10 seconds equals 400 watts. Example 3. 8 ladders, which each ladder has height 20 centimeters, is climbed by a kid which has mass 40 kilograms in 10 seconds. Calculate the power of the kid. From the problems given, H2 equals 8 times 20 centimeters equals 160 centimeters equals 1.6 meters. H1 equals 0 meter. M equals 40 kilograms. T equals 10 seconds. Ask P. To get P, first we have to find work. Work equals minus delta potential energy equals M times G times H1 minus M times G times H2 equals 40 kilogram times 10 meter per second square times 0 meter minus 40 kilograms times 10 meter per second square times 1.6 meters equals 0 joule minus 640 joules equals minus 640 joules. The sign of minus means that the direction of force weight is downward and the direction of displacement is upward, or we can say the magnitude of work equals 640 joules. And to get the magnitude of power, power equals work over time equals 640 joules over 10 seconds equals 64 watts. I think that's all the materials we will learn today. And now is the end of our meeting. I hope with this meeting, all of you can get more understanding about work and power. God bless you.